Hi guys, Shouvik and welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have push dominoes. Yeah, so on that problem statement, they have given n dominoes in a line and we place each domino vertically upright. In the beginning, we simultaneously push some of the dominoes either to the left or to the right. After each second, each domino that is falling to the left pushes the adjacent dominoes on the left. Similarly, the dominoes falling to the right push their adjacent dominoes to standing on the right. First, read the entire English they have written. They have basically prepared very good English, but I don't think so. That on the first go, no one is going to get it. But yeah, they have put some good images also on that you can get it. For the purpose of this question, we will consider that now there is one more line. When a vertical domino has falling dominoes on it from both sides, it stays due to the balance of the forces. For the purpose of question, we will consider that a falling domino expends no additional force to the falling or already fallen dominoes. So that means the dominoes which is already fallen, it is not going to add any forces to it because that domino is already fall to the left or right. Now what we have to return? Now they have given the dominoes representing the initial state. Dominoes of IL, the ith domino has been pushed to the left on the very initial go. R means the ith domino has been pushed to the right. Dot means it is not been pushed at all. And finally, we have to return the string representing the final state. What we have to representing the final state of the dominoes. Yeah. So now we can go to the example test case. On this example test case, you can see that two of these dominoes are falling to the right. Right. This domino is falling to the right, and this domino is falling to the right. And for this domino, one domino from the left falling to the right, one domino is falling from its right falling to the left. So the balance. So the force is going to be balanced at this particular point and it is not going to be fall at any side. The first domino expends no additional force on the second domino. Very straightforward. On this example test case, you can see that is the initial configurations they have given. Now some dominoes are falling to the left. So this domino is falling to the left and its left is, there is no force applied, but it is going to apply a force and it is also going to be fall. So that's the reason it is going to be fall. And similarly, they have like put the diagrams also and final configurations like this to fall left, this middle one is stay at all, then to right, this on this particular domino force is balanced, so it is on stay at all, then left, then right, then left, and finally this to no force applied, and there is no force altogether is going to be applied by successive seconds also, so it is stay at all. Now on the problem statement, it is like on 10 raised to the power 5, so the constant is very high, so you have to think kind of big O of n or n log n kind of things. More than that, it is not going to give you any. Yeah, I think the problem statement is not on the good notes they have put it. I will just quickly explain with the diagrams what they are basically trying to say. Yeah, so where we are? Yes, we are here. Now, what we have at what actually we are doing on the problem statement, what they are actually trying to say us. So they have given us some dominoes. They have given us some initial configurations of dominoes. This one mostly yes. Can I write? I should. Nope, I am not able to write. Why so? Now, yes, now I am able to write. So that is the initial configurations they have given. So some dominoes, let's suppose they have given something like this, L, right. Let's suppose this is dot. So that is the initial configurations of, let's suppose at second 0. They have given to us, and on every next seconds, the fallen domino. So this is a fallen domino, right? This is another fallen domino. This one is another fallen domino. This is another fallen domino, and these are stay tuned. So this domino, when it is falling, so on second one, what is the configurations at second one? Like this domino is going to add a right pressure to it, and this domino is going to add a left pressure to it. So the force on this domino. So what is the second one configurations? So what is the configurations for this? This domino is going to add a right pressure to this domino. So here force is going to be applied, but for this force is neutralized. But for this there is a right force is applied. Right force is applied by the left domino's right fall. So what is the configurations after second one? This domino is going to be fall at right. This domino is going to be fall at right. Sorry, no. This domino is going to be stay tuned because force is neutralized. This domino is going to be left fallen. This domino is going to be right fallen. This domino has going to be falling at right. So that is the configurations. Now on very next go. At second one. second two. This domino is going to be applied a right force. This domino is going to be applied a left force. Other domino, they are already fallen at some directions. They are already fallen. But again, like these configurations is going to neutralize the pressures on this particular domino. So no right pressure, no left pressure. It is going to be stay tuned. So the very second two configurations is going to be same. Is going to be same as above. Right. So like this way. What is the initial configurations? The force is going to be applied every after next second. So when a new dominoes is going to be start falling. So let's suppose on this example test cases, there is one more dot domino. There is one more dot domino where there is no force applied. So on second one, we saw that this domino is started falling to right. So this domino, which is not fallen at all, is going to get a pressures from its right domino, which is falling, its left domino, which is going to add a pressures to its right falling. So on second one, this configuration is not same. This all same, and there is a right altogether going to be added for this. This is not going to stay at all. And next, and for second three, it is same. So on this particular problem, with this particular guidance, we are able to identify that there should be an equilibrium points. Where no dominoes is falling further. No dominoes are falling further. So there should be a point of equilibrium. After that, no state change. Right? No state change happening. So that point of equilibrium, what is the configurations of the dominoes that we have to return in the string format? They have given in string format. We have to return on the string format. Yes, guys. The problem is that simple, but the problem statement is that complex. I personally have to say that is not going to be on the very first bit, is not going to be understandable at all. But yeah, like I guess now you guys are going to get the gist. Now let's think of kind of a solution. Like what the dry runs we did, for that, what the dry runs for second 0, second 1, second 3. What is the dry run we did? Can we get some logic on some from this? We know we have to think of big O of n, or kind of like big O of n log n. N log n should be going to be accepted. Anything fine. So can we say, now I am going to take an examples of the past question, like or it is also a very popular question where it is a multi-source BFS. What's the topic? It is of multi-source. Sorry, what happened? It's going to be on that. Why it is happening? Multi-source BFS. That is a very inky stage, right? So that is a very well-known topic. That is of multi-source BFS. And a popular question on this is rotten orange on a grid. Rotten orange on a grid. So on these problems, basically they have given some rotten orange on a grid, and they are basically asking to the minimum time needed to make all orange rotten, or -1. Like let's suppose there is some orange is not altogether be reachables by the rotten orange. So that orange is going to be stay similarly, like it is not going to be dot, because the adjacent cells which are making the other cells are rotten, it is kind of like non-touchable. So in that case it is not going to be rotten. So this problem is kind of, one variant is minimum time, and another is like final configurations of the grid. Like if you solve kind of these problems, multi-source BFS, then you should be able to solve like very thoroughly. So I have applied like exact same template of my multi-source BFS, and it is going to get a first time accepted. But yeah, like who don't know on the multi-source BFS, I will give you a high levels overview. So how these two problem statements, how these two problems are linked. So there also you see there are some point of like rotten orange, where let's suppose if we have a grid, let's consider a grid, and on that grid, let's suppose this is a point of rotten orange. So from this, the rotten things start to make populated from the grid. So that is a point from where the rotten factors is going to populate from other cells. But let's suppose these cells are empty. This is empty, and here is a good orange. It is good orange. So this good orange is never going to be rotten, because it is going to like, so it is going to be isolated. It is going to be isolated by these empty cells. So the rotten factor can populate from here to which of the cells, let's suppose here is a roten orange. So it makes this orange as a roten, but maybe here is an orange. It makes this orange as a roten. So if this cells is a roten, so then this makes this cells also a roten. But this cells, let's suppose, is an empty. So the roten factor is not going to be populate at the down. So the roten factor is not going to be populate like this way. It is also associated with this empty cell. So the roten factor is not going to be populated here. So if it is going to be populated here, if there is an orange, then it is going to make this orange also roten. So on the final configurations, this cells is not going to be roten at all. Right? Very intuitive and very straightforward. So similar kind of things. We will start our BFS. So before of that, I am making that assumptions that you guys know basic BFS, how we do a BFS kind of things with a DQ or a queue data structures. You are going to have to be handy, and post that you can run your standard templates of how to run basically visited array unit, queue unit. So that basic things I am assuming that you guys are aware of. But if you don't know, please go to my graph playlist. I guess we have make up a video of standard BFS templates of my own. Please go to that. So if you are able to understand that particular video, post that, you can jump on that video. So that's how like you are going to digest my own templates. So the template digestions is not going to make you like uncomfortable if you are coming to this video after seeing my BFS video on the graph playlist. So please go to that video once and post that if you are going to jump on this, then maybe you are on the better state to get quickly grip the entire topics. But if you not, then please follow me. I will try to explain my best with this particular video of my template also. So let's jump on that. Yeah, so we know for do a BFS we need a queue. So on this queue is a visited queue. So we will put the elements which are already visited, and what we need, and we need a queue data structure. DQ, that is a double-ended queue. So more specifically, I can write it as an DQ. So double-ended queue. So what we will do? So initially, for this roten arrange, which of the cells are you going to push your queue from where this roten factor are going to be expanded, from which cells the roten factor are going to be expanded, you are going to push that cells only. So on these particular problems, which are the roten cells? It is nothing but, if you are running a loop for I in range n, if that cells is either holding an left or it is holding an right. I am writing pseudocode, guys. I will explain my exact code letters, but here I am explaining the pseudocode. So on this particular, I am just giving you the intuitions building capability and the pseudocode writing, so that you can feel the problems in your blood veins, so that you can on very next go, if you are going to face similar problems, you are just very comfortable to write that. So that's exactly what I am trying to build. So I know. So to make the final configurations, I have to start my BFS from the points which are actually spreading the roten things. So for this particular problems, we have some cells which are falling to left, and we have some cells which are falling to right, and we have some cells which are standing at equilibrium. It is not falling. There is no pressures altogether or force altogether not applied. So we are pretty sure that for the cells where the pressures is altogether not applied, for them they are not falling to left or right. So which of the cells is first starting the non-equilibrium of the entire of our configurations? The fallen cells, the pressure applied cells. So that's the reasons we are going to push in our queue. Which of the cells we are going to push the index and either left or right. What is the value to it to our queue, and we are going to mark them to be visited. We are going to mark them to our visited array, that these cells we have altogether visited. We are marking them with 1, and what we will do, and we are going to push, we are marking that particular answer of that either right or left, whatever the value it has. So that is the initial configuration that I can think, that where the pressures is right applied or where the pressures is left applied, that cells are finally going to be filled to the right or left where the pressures is applied. So we can make to our answer array to the right and left to the initial configurations of that particular cells. And for the cells which are in equilibrium, we will find either they can fall to right or either they can fall to left. That we will find with our BFS. And we are marking who are altogether the pressures applied cells to our visited array. And post that. So that is the initial configuration. Post that, we will run our very standard BFS template while len of queue. We have to iterate till this point, and we are making how many sites, what is the elements which are on that particular second are falling. We are going to take all of them. So we are making len of queue. What is the len of queue? We are putting them in a variables, and we are making the we are performing the fallen things, pressure things on the new cells to the current go. So how we will do? So we will iterate for I in range of sites. We will do whatever the fallen cells which are already falling, where the pressures can be applied, what the pressures can be applied, right? For the new configurations where the pressures can be applied, and we need a dictionary. I will explain why. Default dict of int, the same things that we are doing for very first book, so that we will do. And so now we have to find, so this for loop is going to do what is the that particular second configurations. So for a particular second, which of the new cells, which of the new cells are all together we can accumulate, which of the new cells we are all together accumulate. So here you can see on the very dry runs also we have written in the second perspective what is the configurations on second 0, what is the configurations on second 0, what is the configurations as second 1, what is the configuration as second 2. So similarly I am writing what is the elements which are falling of that particular queue. So this particular queue is holding what is the last fallen cells. So that particular fallen cells I am going to collect all of them, and we are going to apply the pressures to its adjacent. And who are the adjacent? Left, it is nothing but my I will do a q dot pop left, and q dot pop left if we will do, then the first element is the index and the second element is the directions where it is falling. First element is an index, second element is the directions where it is falling. Now we will, what is the adjacent? It's left and it's right, because it is an one dimensional BFS we are doing. For grid we have to check 4 directions. Now we have to check on 2 directions, left and right. If my index -1 is greater than equals to 0, if it is altogether is in boundary, and what factors we have to check? This visited of index -1, that these cells should not be visited at all. So if it is equals to 0, and whatever the things, and this cells is altogether not fallen on the previous go, or not together fallen from the previous go. So how we will check? The given what they have given to us, I think Dominoes they have given to us. They have given some Dominoes, but yeah, that's not needed. So now when it is going to apply a pressures to its that is the left pressures we can get. What is the left pressures? What is the left pressures you can get? So here you can see. So if that particular cells is falling to the left, if that particular elements is going to be falling to the left, right? If the current elements is falling to the left, if the current elements is going to be falling to the left, then it is going to apply a index -1 pressure. When it is going to apply a left pressures, when it is currently falling to the left, right? Then what you have to do, you can increase your this particular index -1 is going to be falling to the left. I will explain why we need to push in that dictionary. Please stay tuned. Please understand this. And similarly, when it is this right conditions, I think you guys can write on your own. Index +1 less than n, and what is the factors? It should not be in visited, and it is an directions should be equals to right. If that is so, then you can do the exact reverse. Your index +1, that cells is going to be, I will add +1. So for left fall I am subtracting some things. For right falls I am adding something. So these all are the new cells, which all the cells in our dictionary. So our dictionary is holding which of the new cells we can explore, right? Sorry, we can explore. What is the new cells we can explore altogether? Very straightforward. Yes, right, exactly. So on that particular cells, now there is a factor on these particular problems. Some cells has some equilibrium, Here you can see where a vertical domino has falling on its from the both the sides, it stays still due to the balance of the force. So that is a beauty, I have to say. So that's the reason I took a dictionary. I am not considering that particular which of the cells are next is going to be fall. I am also considering what is the pressures is going to be applied. So how I am doing? If it is falling from the right, I am adding a pressures +1 factor to it, and if it is falling to the left, I am subtracting a -1 factor to it. So if a cell is going to hit a right pressures and also a left pressures, is going to be neutralized to our dictionary, is going to be stored as a 0 pressures to it. Now we are only going to consider for each in our dictionary, we are going to iterate to our dictionary, and if this dd of each altogether has some value, so that means it is not an 0. So the pressures is altogether going to be applied to this. Now if the pressures is applied, right? So if it is equals to 1, that is a right pressures is going to be applied, then I am marking to this each index to be a right value to my answer, and I am pushing this value to what is the same things I have done. I have to do the same things here. I have to pushing the index, each is the index, and the factor is right factor to do next pressures, next second pressures to the further of its right, to the further of its right. It can, so that it can apply the pressures, it can carry further pressures, and I am marking the same things, marking this particular each index to be a visited. Same things I have to write for, same things I have to write for left, same things I have to write for left. And finally, let's suppose, and when we are able to find a such candidates, we are marking our falling. Okay, so with current seconds, are we able to make any changes to our state? So that basically stored by this falling. So we will mark our falling to be true, either to the right or either to the same left configurations also. We will mark to our falling to be true. And before starting our dictionary, I am taking a variables falling initially as false, and how I can say that on the current state we are not able to change the configurations. If my falling is altogether is false, so that means on the current iterations we are not together make any state change. All are in equilibrium. There is no state change. So do we need to iterate further? No. We can directly return as we are pushing the values to a list. We can do a join with empty things with our answer list. And if altogether it is not going to be hit, then finally after our this loop we can do the same dot join of answer. If it is not altogether going to be enter to our queue, and if that state is not going to be at all encountered, or let's suppose when it is not going to be encountered, when let's suppose we are going to exhaust to our queue, when we are going to exhaust to our queue with the before of that. So where I have written, so that is of this, I'm writing for this index -1. Okay, so on this particular points, when we are going to start our BFS on the queue, so let's suppose our queue is altogether empty, so we are not able to encounter a right fallens, left fallens, or whomever we have encountered, the force factor is going to be neutralized, so there is no new elements is going to be pushed. So on that case our queue is going to be empty. So what is the configurations we have at, we are going to return from the outside of this while loop, outside of this one. Yes guys, the problem is as simple as that. Now we can quickly go to the code iterations once. So yeah, so here you can see I have took n equals to len of dominoes, vis and so that is our visited. Everyone's is going to be on the very first go is started with 0n, and answer is going to be I am start with everyone's is on equilibrium initially to my answer, and I have initialized my our queue to a dq, and I am writing a for I in range n. I have whoever is falling to the left or right, whoever at the rotten range, that is actually the multi-source BFS, that is actually the starting point of my BFS. So I am appending the indexes and the fallen factor. If it is right, then I am adding right, or if it is left, and I am marking them on the same go visited, and I am marking the answer of I to either left or right. And then I am doing while len of q, the same thing, standard BFS I have DD, standard BFS. And when size len of q DD of default dict, when I have pushed the index and the directions, if index -1 greater than equals to 0, that within boundary direction left, and visited it is not visited, then subtract a pressure from it, so which is going to be indicate that it is a left fallen, and if it is just of reverse, we are adding a +1, then that means it is a right fallen. And we have start with the falling factors to be false, and when we find the falling factor, that means there is a state is going to be changed, either by we have found in our certain elements which is not altogether visited earlier, because we are only pushing if it is not visited, and it is falling to the right, so there is a state change. So falling is still true. So there is still not we have encountered to our equilibrium state. And similarly for -1 we are pushing to left, and visited we are marking. And finally, if our falling state is false, so that means we have land on our equilibrium. We are returning to dot join of answer. And if this while loop is going to be executed without a falling factors to be false, so that means we have exhausted of the left fallens or the right fallens things. So we are returning an empty answer from here, right? So you guys might be not able to understand why an extra return is going to be required. If it is altogether, it is bound to land on this particular false block, right? For when there is no state change, but let's suppose there is a test cases of something like this dot. So if that is the test case, so there is no left and right fallen things. So if that is the case, so that means we are not going to add anything to the queue, and our len of queue is every times empty. And finally if we are not going to return anything, then functions is by default returning null, and you are going to get a wrong answer for that particular case. So you have to explicitly write if it is altogether out of the while loops, you are whatever the answer you have had, just return it. Yes guys, so the problem is as simple as that, but to fit the multi-source BFS of this particular problem, I think it is a kind of obviously a tricky until you have solved a numerous number of graph BFS, multi-source BFS kind of things, and if you're not able to solve the very popular root and orange problems, then mostly you guys are not able to like put the BFS on the very first go, how it is going to be set on this particular problems. But yeah, like on very first go, I already solved that root and orange, and on the very first naked eyes, I am just think of the multi-source BFS only, and I have applied to this and got I see on the very first go. But I have written the discuss sections and some of the posts also. I think this problem is also going to be solved with some forward backward loopings also. But yeah, I personally feels that when you have to set a particular known algo, when you are going to fit that particular algo to it, explaining that and like writing the code is like less error prone code actually, because if you are writing an intuitions based code, then I personally feels the wrong answer or error you are going to encounter is just chance of is going to be more, and explanations is also going to be complex. So if you are going to encounter any kind of problems to your interview, and if you already solve if you are able to fit your known template algo to this, please do that. Don't try to make more generalizing, more intuitions based, then you are going to get some of your edge test cases is going to be filled. So that's the reasons I am on the very first go writing the same things. So now quickly discuss the time complexity. I think so we are just visiting every elements at max once times. So that is a very standard BFS we are doing. So the time complexity of big O of n, I am not considering this initializations things, because on like graph based BFS things we are there. I am agreeing that is a 3n, 1n, 2n, then returning the answer is altogether going to be n. So 3n, 4n, 5n, there can be this kind of complexity. But yeah, if you are encounter the problems of BFS kind of things or DFS kind of things, then you can easily, like on the very first go, you can tell the exact like big O range complexity. That should be like mostly fine on most of the interview. So here the actual gist is how you can organize it, write your code, how you can set your template on the particular problem. That actually interviewer trying to see here. So yeah, on time complexity, it can be of 3n, 4n, 5n. That factors I am not going to be jump on that. Mostly it is of 2n here, another in 3n here, and returning an answer is an 4n. So 4n or at max 5n kind of complexity, if I am going to write in more granular, that should be this. And space complexity, as we are using a queue, it is going to be a take of big O of n, and this answer I am not going to consider because that we have to return anyhow. And queue complexity I can take it, so that is also a big O of n. So the space complexity we are using of big O of n. Yes guys, so that exactly the most optimal time and space complexity for this particular template based solutions that I am able to think of, and I am pretty sure that is mostly like big O of 2n, 3n, maybe kind of optimizations. Some of the like forward backwarding loops can be do, maybe they can do in big O of 3n mostly. But yeah, I personally feels like if you are able to set a BFS kind of template to this particular problems, that is like quite awesome. So that's the reasons I am personally like explaining this problem on a different perspective. And if you guys are able to understand till this point, so please do subscribe to our channel. I guess you are already doing, and please share the videos to your friends circles who are also preparing for top product based companies, so that they can also do their brushing up their DSS skills. And please turn on the notifications so that when we are going to live to our next video, you will get the notification as soon as. So that's it guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys, bye.